Understanding what a rational number is, in simple terms, a rational number is simply a number in a decimal form whose block of digits terminates or repeats. So in short, these are decimal numbers. However, they are of two forms. The first one is a terminating decimal number, and the second one is a repeating decimal number. So a terminating decimal number is a number which does not have the repeating figures. For example, if we have 0.75, just like that, this is a terminating decimal number because it has an ending. However, if we look at a repeating decimal number, for example, we can have 0.3333 and so on. This one is called a repeating decimal number because this figure here does not have an ending. So we have two types. The one that does not have an ending is called a repeating decimal number, whilst the one that has an ending is called a terminating decimal number. So that's very, very important to understand. Okay, so a rational number can also be expressed in form of a fraction where we have a over b, where these two figures a and b are what? Are integers, and b should not be equal to 0. So if we have such a fraction where b is not equal to 0 and those are integers, then this can also be classified as a rational number. So it's not only the decimal points, even the fractions. So let's say we have 3 over 4. This is a rational number. If we have, let's say, 20 over 10, this is a rational number. Let's say we have 7 over 1. This is also a rational number. If we have 4 over negative 3, this is also a rational number. So in short, any fraction can be called a rational number, provided that the denominator is not equal to 0. Apart from that, the other type of a rational number that we need to understand is a perfect square. So the examples of rational numbers which have the square roots of perfect squares, for example, let's say we have 1, let's say we have 4. Okay, this is too big. Let's say we have, let's say 9, we have, let's say 16, and so on. These are perfect square numbers because the square root of 1 is simply 1, the square root of 4 is simply 2, the square root of 9 is simply 3, the square root of 16 is simply 4. So these numbers are called the perfect squares of these square roots. So since these square roots have the perfect squares, this case then, they are called the rational numbers. So the numbers that are the square roots of perfect numbers are also classified as the rational numbers. So we have talked about 3 things that are classified as the rational numbers. The first one is a decimal point, where we have either the terminating decimal number or the repeating decimal number. The second one is where we have a fraction in form of a over b, where b should not be equal to 0. This one also is classified as a rational number. For example, let's say we have 3 over 4, let's say we have 7 over 1, let's say we have 2 over 7, and so on. Apart from this, even the square roots of perfect squares is also classified as the rational number. For example, square root of 1, square root of 1. Alright, so let's say square root of 1, square root of 4, square root of, let's say, 9, square root of 16. All these are classified as the what? The rational number. So the perfect squares are classified also as the rational number. So there are 3 types: the decimal number, the fraction, and also the square roots of perfect squares. So make sure that we understand this. However, a repeating decimal number can also be represented using a very simple symbol called a bar. So instead of writing 0.3333, we can write this by simply representing the repeating numbers with a bar on top. So if we have a bar on top, it means that the figure that we have down there is repeating itself. Okay, so instead of writing the numbers with repeating numbers, or rather the decimal numbers with repeating figures, we simply write them with a bar on top of the repeating figures. Okay, so all the figures which have this symbol here up there is called a decimal number or a rational number. This can also be called a rational number. Okay, so now in this lesson we are going to discuss how we can express the given different rational decimal numbers into fractions. So let's say, for example, we have been given 0.3, and then we have been asked to express in the form of a over b, where a and b are integers and b should not be equal to 0. So how can we express this decimal number in form of this fraction? How can we do that? So the first step is to let this decimal number equal to what? X. So we say let x equal to 0.3. The next step is multiplying the number of figures a bar has covered. So if it has covered one figure, we multiply with 10. If it has covered two figures, we multiply with 100. Likewise, if it has covered three figures, we multiply with what? 1000. So that's one of the concepts that you need to keep in mind. So since this bar on top here is covering up only one figure, it means that we are going to multiply this equation here with 10. So we are going to multiply both sides, the left side and the right side. So if we multiply x with 10, we are going to have 10x. And then if we multiply the right side with 10, this figure here simply comes to the left. So in this case, we are going to have 3 and then point. You write the repeating figures, or figure in this case. After we are done with this part, then you subtract the first expression from the second expression. So in this case, we are going to have 10x equal to 3.3 and the bar minus x equal to 0.3 with a bar. So let's subtract the two. So 10x minus x, what are we going to have? 9x. So this equals to, now 3.3 with a bar minus 0.3 with a bar. So in this case, we are just going to say 3 here minus 0. We are going to have what? 3. And then this is going to cancel each other. So in this case, we are first going to divide with 9 so that we can just remain with x on the left side. So 9 and 9 there will cancel. So in this case, we are going to remain with x equals to 3 over 9. After we are done with this part, if you can simplify further the given fraction, you have to do likewise. So in this case, we know that 3 can go in itself one time and it can go into 9 3 times. So in short, x equals to what? 1 over 3. So in this case, we have expressed that 0.3 with a bar on top is the same as 1 over 3. So this is the answer. So if you want to prove that the right side equals to the left side, all you have to do is divide the fraction, and you will see that it will going to give out it. So you will see that it's going to give you what? The value of the decimal numbers. So let's look at the second example. Let's say we have 0.24 with a bar on top. So how can we express this in form of a over b, where b is not equal to 0? So in this case, the first step, like we have said before, the first step is to let x, okay, so is to let x equal to the given expression. In our case, it's 0.24 with a repeating figure. And then the next step, as we can see here, the number of figures a bar has covered is what? Is 2. So in this case then, we are going to multiply with 100 to both sides. Left side, when we multiply with 100, we are going to have 100x equal to, when we multiply the right side with 100, of course this figure will just come to the left side, so we are going to have 24 point, the same repeating figures, that is 24. So after we are done with this part, the next part is to subtract now. The first expression we subtract from the second expression. So we are going to have 100x, which of course is equal to 24.24 minus x equal to 0.24. So when we subtract 100 minus x, we are going to have 99x, which of course this is equal to 24 minus 0 is 24. Okay, and then this is just going to cancel each other. So in this case, let's divide 99 to both sides, even here. So in this case here, we are just going to remain with x, so it's going to be x equal to 24 over 99. So like I have said before, if you can simplify the expression, make sure that you do likewise. So we know that this can be simplified further, because 3 into 24, it goes 8 times, and the 3 into 99, it goes 33 times. So in short, x equal to 8 over 33. So we have shown that 0.24 equal to 8 over 33. So this is the answer. So if you divide 33 into 8, we are going to have 0.2424 being repeated several times. So this is the answer. Now, what if we have been given an expression which does not have a 0 in front? Let's say we have been given 1.23. Well, it's just the same case. So for us to solve this kind of an expression, to express this in form of, let's say, p over q, where q is not equal to 0, to express this decimal number into such kind of a fraction, the first step is to let what? X equal to 1.23 with a bar on top. After we are done with this, the second step, as we have been doing before, is multiplying with the number of figures this bar has covered. So it has covered how many? 2 figures. So we are going to multiply with 100. So 100 multiplied by x, we are going to have 100x. And then 100 multiplied by 1.23, we are going to have what? 123.23 repeated. Okay? So when you are multiplying, you simply have to let this come to the left side, as I've been doing. Then the next step from this is subtracting. So in this case, we have 100x equal to what? 123.23 with a bar minus x equal to what? 1.23. Okay, with a bar. Then we subtract. So 100x minus x, it's 99x equal to 123 minus 1. Okay, it's 122. And then this will cancel each other. So here we are just going to remain with 99. Even here, 99. So this 99 will cancel each other, and then we are going to have x equal to 122 over 99. Okay, so in short, 0, or rather that was 1.23 with a bar is the same as 122 over 99. So this is the answer. So make sure that you understand. So it's the same concept, right? Yeah, of course. Now let's look at the last example, where we have, let's say for this one, we have 0.785, and then a bar is on 85. Take note that 7 is not part of this expression, so rather it's not part of the bar. So how can we go about this one? So make sure that you subscribe to the channel, you like the video, and share it to others as well. Okay, so let's not waste much of the time. So to answer such kind of an expression, the first step is letting the given expression equal to x. So we are going to say x equal to 0.785 with a repeating figure. The next step is multiplying with the number of figures which a bar has not covered. So in this case, this bar here on top here hasn't covered what? 7, and 7 is one figure. So firstly, we are going to multiply with what? With 10, so that we can let this figure here come to the left side. If we had two figures, let's say we had one here, if we had two figures, we could have multiplied in this case with what? 100. So the number of figures which a bar hasn't covered is the number of zeros you have to multiply. So in this case, we only have one figure, so we are going to multiply with 1 0, that is 10. So 10 multiplied by x, we are going to have 10x equal to 10 multiplied by this figure here, we are going to have 7.85. Now, remember we have 85 here, which is a repeating figure. So it has covered how many? 2. So in this case then, we are going to multiply with what? With 100, since it has covered 2 figures. So 100 multiplied by 10, we are going to have 1000 x equal to, now 100 multiplied by these figures we have here, we are going to have what? 785.85 with a bar. After we are done with this part, the next part is subtracting the second equation, which is this one. We subtract from what? The third equation. Okay, so what are we going to have then? So let me just wrap the top part here, since we don't need it anymore. Okay, so let me just write this properly. So we have 1000 x equal to 785.85 repeating bar. We also have 10x equal to what? 7.85 with a repeating bar. So let me just wrap now the down part here, so that we can use the space. So in this case, let's subtract the two. So we are going to have 1000x minus 10x. We are going to have 990x equal to 785 minus 7. What are we going to have? We are going to have 778. And then this is going to cancel each other. So let's divide 990 here and also 990 here. So in this case, we are going to cancel this, and we are going to have x equal to 778 over 990. So if you can simplify further, well and good, you can do likewise. So in this case then, we have shown that 0.785 is the same as 778 over 990. So you can simplify this fraction if you want, but if you're leaving it that way, it's okay. So in this case, this is our answer. So I'm sure you have gotten the concept. The first one is you let x equal to the given expression. The second one is multiplying with the number of figures a bar has covered. And the third party is subtracting. Now the second expression you subtract the first expression. Apart from that, if you have been given the figures which are not being covered by the bar, you first multiply the number of figures not covered by the bar, and then you multiply the figures covered by the bar, and then subtract. Thanks guys for watching up to the end. Hopefully you like the video, and then subscribe to the channel, and stay blessed.